Just to be very honest with you, when I was in J1, my vectors was really super bad. So I was just telling my J2 students a few months ago, like this, that I'm telling you guys now. My vectors was very bad throughout my entire J1. And I think it was only until around the middle of semester 1 in J2, then that was when I started to feel that I must really do something about my vectors, because A-level is coming. Then J2 is going to be so ridiculously hectic. So I decided that just one day, I decided that for that one day, right, I'm not going to do anything else. I decided that I should probably sit down and just look at my vectors and see whether I can sort out what went wrong. So I put myself, personally, I like to study by myself. I don't like people around. I don't like to study with friends. So I sat in my room. I looked at my vectors lecture notes. It was a bit difficult to start in the beginning, but after a while, right, when I really spent some time looking through my lecture notes, and then not just looking at all those formulas, I just thought I should read everything. So when I started to get a bit more warm up, and I start to look not just at the formulas, but look what the lecturers has explained before the formulas, right? Everything start to make sense. I was even feeling a little bit silly, like how can I have messed up vectors so much? So I was taking in all the vectors stuff, and I remember the week that was after that was a test. And guess what? I messed up my whole vectors for the entire J1 until the middle of J2, right? But after that one day that I've spent sitting down, really making myself look at vectors, yeah, the test that I did was almost 100. And I was definitely very happy. So I was sharing with my J2 students that. And just a few weeks ago, I think about 2-3 weeks ago, one of my J2 students was telling me he did that. He did exactly that. He spent one day looking through his vectors, and he realized that it was really not that bad. And he had the test after that. And he told me he probably scored almost full marks or so. So I do want to try this with you guys, just in case any of you, right, are finding vectors really difficult. Not that this 1 hour thing that we are going to be doing is going to make such a big difference immediately after we finish this 1 hour, but I'm hoping to tell you how I spend that one day, right, looking through my vectors. And hopefully you can also consider spending one day during this June holiday to just sit down and look through vectors from the same perspective as I did. Because to me, when I try to look at vectors, hang on. Oh, yeah, sorry, Michelle. Do you mind helping me to just send the materials to the students? Just one send to everyone so that, at least every one of you has the material. Okay, is there anyone who didn't get the material for today? This is one set of outline that I super like. I'm going to tell you why I like this. Okay, so I'm going to continue. Okay, Michelle, do help me to attach to send to everyone the soft copy on the Zoom. So anyway, when I was talking to students now, a lot of students complain to me, the students who didn't do well in vectors, because vectors is actually a very easy topic. But students who didn't do well in vectors, right, they always complain that, oh goodness, there are so many formulas that they are supposed to memorize. Okay, there are indeed a lot of formulas to memorize, seemingly a lot of formulas to memorize, but I do suspect also that for students who keep complaining about the multiple formulas that they are supposed to memorize, right, they might have skipped something that is even more important than those formulas. Because to be able to do vectors well in exams, to when you are doing questions, when you're trying to solve problems for vectors, right, we have to, it's not even an option, we have to go through 2 phases. The first phase is how we visualize the geometrical situation that is presented to us as a problem. And then the second phase is when you start to write down and start to do your calculations. So there's this visualization and there's this calculation. But what I think a lot of people did, which was what I did when I was in J1, right, is after I've gone through the visualization part with my lecturer, I thought that was just an introduction to the formula. So after that, right, my focus is always on the formulas, always on the calculation. I didn't know that the full solution consists of also the visualization part. And I didn't know that H2 Math does not take up the burden of helping me to visualize. Because I realized that no one can actually help me to visualize unless I plan to take a look at the situation myself. So that was what I was waiting for in J1, waiting for the formula to start to make sense, but I skipped the visualization, so it never makes sense. And when I realized that maybe I need to do a bit of visualization, I wait for the teacher to help me to visualize, and the teacher cannot help me to see things. It's only up to me, right, who have been living for that 18 years, 17 years, 18 years, who want to then make use of how I have perceived the world, all the 3D stuff that is around me, right? That will help me to visualize on that day when I look at the exam question. So that visualization, just to share with you, okay, no one can teach you to do that unless you are willing to take a look at the situation. And most likely for H2 Math, the situations, the geometrical situations are not that difficult to visualize. For example, let's try it out. For example, right, let's take one of the more basic scenario that we have come across in our vectors, okay? How about taking this particular scenario here? Length of projection. So if I have this vector A and I have this vector B, I just want to show you, just in case, okay, just in case for length of projection, for some of you, the first thing that comes into your mind is which formula am I supposed to use? In case that is you, right? I mean, if it has been working well for you, fine, okay. But if it doesn't work that well for you, right? Can you try to do what I'm trying to do on the board, like right now, and then simulate it again for that one day during your June holiday to try to do what we are just doing here. So we are supposed to have a situation that is like this, and the question requires us to find the length of projection of vector A onto vector B. My aim in solving this, right, of course, it is to find this length. Okay, I'm trying to find this length over here, but my full solution must take into account of one part that I'm not writing, which is going to be me looking at the situation and thinking, what geometry am I looking at? What is it in math, right, that probably has taught me something that can help me to calculate the thing that I want to calculate for this. For example, let's say, okay, which is let's say for a situation that is like this, what if the question gave you vector A and what if the question give you vector B and the question happened to be giving you this. They say that this is 5 units. How do you find this? Are you going to use dot product? Of course not. Because you know the situation that is here, how you're going to find this is by using maybe just a Pythagoras theorem. It is easy. You just find the right tool, right, for the situation that you have paused and think about. Usually it will be way easier than focusing on what you are writing before you even understand the situation. But what if this is not given and what you are given is only A and B? If I'm given just A and B, what are the methods that I can use to solve this? I guess I'm going to make use, I mean, if this is vector A, if this is vector B, and it exists in a 3-dimensional space, I think one of the tools that I have learned only in H2 Math, I didn't learn this in secondary school, is making use of dot product. I think dot product is a super useful tool for us to do H2 Math question. Let me write it down here. So number one, I'm going to make use of a tool. The tool is dot product. It is not a tool that is unfamiliar to us. So let me write it down here. A dot B, this is equal to modulus of A, modulus of B, cosine theta. And I do have the aim of making dot product to be as familiar to myself, right, as Pythagoras theorem. Because just now, the moment when I wrote this, right, I can already see Johan say, Pythagoras theorem, I don't even need H2 Math to teach me Pythagoras theorem. Why do I want to use dot product? Because, right, I know that if I were to use dot product, and since I have vector A and vector B, I can actually do a calculation. I can calculate, for example, this angle here. I can calculate theta, right? That's what dot product can help us to do. If I were to sub A into that formula, if I were to sub B into this formula, theta, which is the only unknown, if I can calculate it, you know what else I can do? I can make use of the torcasol that we have learned in our secondary school, right? Because in our secondary school, if we were to look at a right-angled triangle that is like this, if I were to look at a right-angled triangle that is like this, where I have a right angle here, if I have an angle theta here, if this hypotenuse here is r, and if this is x, if this is y, and if I'm supposed to find x, right, then I'm going to be making use of cosine theta. Cosine theta is going to be equal to x over r, which means that x is equal to r cosine theta. So if I were to just try to replicate this here, right, this length here is going to be modulus of a, because this has a length and that length can be obtained by vector a. It is going to be modulus of a cosine theta, which means that if I am able to find this theta, then I can substitute into here and I can make use of modulus of a. Then I can complete my entire process. I can find the length of projection. This is a whole process, right, that started off with me pausing and thinking about the situation. Then we slowly make use of different tools that we have learned in our math from secondary school all the way until now, right, to see how we can calculate something that is like this. But what we can do even better, which is then the lecture notes is going to be helping us quite a bit, is yes, of course, what I've just mentioned, right, can help us to find this length, but we can do it even better if I were to pause even that little bit more longer, right, to take a look at the tool that is given to me. Because if I have a situation that is like this, where I'm given vector A, I'm given vector B, and we are supposed to find the length of projection, through my secondary school, I have learned that the length of projection, if I have the hypotenuse, through Torcaso, I can find this as modulus of A cosine theta. And isn't this cosine theta the same as the cosine theta that is over there? Which means that geometrically, I can already understand that this length is modulus of A cosine theta. But what if I bring in the two a bit earlier? That means before I even find theta, right, I already bring in this. That means if I were to work on this as A dot B is equal to modulus of A modulus of B cosine theta, then I will realize that I don't even need to find theta, because within this equation that is one of the new tools that I've obtained to help me to handle geometries now, I already have modulus of A cosine theta. Which means that if I can just manipulate this equation to make modulus of A cosine theta the subject, I can find this even faster by doing A dot B divided by modulus of B. And since length is a positive number, and we do know that A dot B can be plus or minus, maybe I should just do a bit of improvisation to my dot product equation by adding a modulus to it. This is how I derive at the formula. And this formula can only make sense if there's a part that you trigger your visualization. For example, what if now I am interested to find this length? Okay, I'm interested to find this length. And to find this length, I look at the situation that is given to me. If this were to be the one that is theta, if this were to be theta, then using Torcaso, this will be modulus of A sine theta. This is geometry. I see this first because I'm looking at geometry. And this geometry has been learned. I don't even need to learn it again. So this is modulus of A sine theta. Is there a tool that can help me to solve for this? Of course, I can use dot product to find theta again, but is there a better tool? Yes, we do have a better tool. The better tool that we have learned to make use of in our H2 math, right, is cross product. It is cross product, but okay, can I just tell you something about this cross product? Cross product has one huge formula, which is one that is here. So for this particular formula here, right, I do think it is a good tool to make use of. A cross B, this is equal to modulus of A, modulus of B sine theta, and an n hat. But personally, I find this particular formula here, right, not the most useful version unless I am trying to find something that is perpendicular to A and B. That means this is useful to find normal. But other than finding normal, right, I personally don't find this that useful as an equation to quote. So the reason is because if I'm trying to quote an equation, I mean, what is the purpose when we try to quote equation? When we try to quote equation, we are trying to make use of the power of equal. Whatever that I do on the left-hand side, I can do on the right-hand side, which will allow me to do, like cross, I can't remember what that is, like divide things over to the other side, But if it were to be vector and vector, I know vectors cannot do that division thing. Scalar is possible, vectors cannot. So as an equation, right, this particular equation here is very, very inflexible. So other than the purpose of using this equation to help me to find like normals, other than that, I don't think I can make use of it unless I can make it scalar. So the equation that is actually a bit more useful than this, right, is this number 1 over here. It is when we try to apply an overall modulus to this whole thing, which means that on the left-hand side here, we will have a modulus of A cross B. And since modulus of A is a positive number, I can take it out of the red colored modulus, so I have a modulus of A. Modulus of B is a positive number, so I can take it out of the red colored modulus. It is modulus of B. How about sine theta? Sine theta is also going to be positive, isn't it? Because for vectors, we have sort of like in our syllabus, right? We have defined vectors angle to be always in the first or the second quadrant. Add sugar to coffee. First, second quadrant, sine theta is always going to be positive. So sine theta is also positive. So I can take it out of this, which will leave me with just it is going to leave me with just a modulus of n hat within here. And n hat is a unit vector, so modulus of n hat is just 1. So it is multiplied by 1. And personally, if I were to use an equation other than having a normal that is necessary, right, I will probably use this one. So let me write down this. This is super useful. Modulus of A cross B. This is modulus of A, modulus of B, sine theta. Because, right, this is exactly the equation that I'm going to choose to try to find this particular length over here. For this length, I have through my visualization, which I don't want to depend on schools, I don't want to depend on watching a video, right, such that I can start to learn how to visualize. I just want to visualize. I just want to make sure that I spend some time to look at the situation, then think of what kind of geometry am I looking at myself. So I look at the situation, I know that I'm looking at a right-angled triangle here, and using Tuakaso that we have learned in our secondary school, I'm really starting to use some math tool to process my what I'm visualizing. So I realized that this is modulus of A sine theta. Hey, nice. Modulus of A sine theta is here. So what if I were to just code this equation A cross B, but I'm going to use the version with a modulus. So it's going to be mod A, mod B, sine theta. Then making mod A, mod B, sine theta the subject. Then this is going to be modulus of A cross B divided by modulus of B. And this is what I see in my lecture notes as the formula. But it is not just the formula that I need to use. I need to use the whole process, the visualization part, together with the tools that you're going to use to calculate what you have visualized that will form my entire solution to vectors. Without that first visualization portion, I don't think vectors will be easy. Even if you are able to score, it is not going to be an easy question. With visualization, you may not be able to score full marks all the time, but it is not going to be the topic that is the challenging one. There are more difficult topics to have. For those of you who are doing J2, how difficult it is to do P&C question. You can understand my pain, right? I mean, personally, I don't like P&C also. I mean, I like P&C, sorry. I like P&C. It's just that I don't like to do P&C questions when my students suddenly just throw it to me, then I'm so tired, I got to think about it. But personally, if I were to just sit down, I have some time to think about it, I don't mind P&C. But anyway, we are talking about vectors. So vectors need that visualization portion. Without the visualization portion, the formula, most of the time, it will not work. Can I just refine the idea of this with you guys like a little bit more so that it is easier for us to apply if we were to see situations that is like this? Because together with my tuition class, we are calling this the magic triangle. That means this magic triangle, right, is a visualization that we have pre-thought of. So that whenever we see a situation where I need to find distances, I'll try to apply this magic triangle. Okay, again, this magic triangle is a visualization thing, okay? When I say apply, I'm not saying that, we're trying to apply as a formula, but it's just to apply as part of the process that we're going to be analyzing the situation. So, in general, right, when you're trying to find a distance, what you want to do in vectors, okay, when you want to find a distance, right, you want to try to find a triangle as part of your visualization. And you hopefully can find it as a right-angled triangle. In our syllabus, actually most of the time, you will be able to find a right-angled triangle. We're going to try it in a short while. So I want to find a right-angled triangle. This is the first thing that I'm going to try to do to just refine our visualization a bit. Okay, I mean, our visualization is very, very powerful. I mean, just in case any of you has some doubt about your own perception of the world, right? You are way more powerful than you think, okay? Our visualization is very powerful, But it's not that everything that I can see, right, math can already help me to calculate. So what H2 Math is trying to do is to refine our visualization a little bit so that at least we are a bit more focused on trying to visualize, not everything, although there are a lot of things we can imagine, but refine it so that from certain perspective, right, they can at least be calculated through math. Okay, so that's what I'm trying to do to identify this magic triangle with you guys, okay? So the first thing is I want to find a right-angled triangle. And for this right-angled triangle, it will become magical if it also has the hypotenuse that is already known to you. And very, very often, the hypotenuse will already be known. So modulus of A is the next thing that I want, the length of the hypotenuse. But the last thing, right, is actually the most crucial. And sometimes when people apply this triangle, the reason why their triangle has never been magical is the last thing. This last thing, right, it is trying to continue with your visualization, but yet being very, very familiar with the kind of tool that you know how to, the kind of tool that you have, right, for H2 Math, which is this tool, dot product and cross product. Because, right, the last thing that I'm going to put down here in order for me to form my magic triangle is actually the angle. I will be using torcaso, the angle. But take note, they're actually, if I were to be drawing this whole thing from scratch, I only have A and have B. The triangle is something that I'm trying to visualize from the situation. Number one is I'm trying to visualize from the situation. Number two is I'm trying to visualize from the situation. And if I were to try to apply torcaso, I need a theta. And there are two thetas. There are two possible positions for theta. One theta is here, the other theta is here, isn't it? Two thetas. Which one should I use as a theta? That's the question. And that is actually the thing that was missing in your secondary school. Secondary school, they gave you theta, then you apply torcaso directly. This time, I choose my own theta. And I chose it based on two new tools that we have learned in our H2 Math. These two. Because I know dot and cross product involve an angle that is between the two known vectors, A and B, right? That is why between the two angles that are actually still not assigned to be theta, after I've chosen this and this, right? Before I chose this, I need to choose an angle theta to be the angle that is between two vectors that I know. So I intentionally choose this theta. It is not a random process. Here or here, here or here, 50%, no. I intentionally choose this angle because this is the angle that is between two known vectors. Then I can bring in my dot product. Then my dot product can help me to calculate things fast. What if you were to choose? Okay, let's not talk about it. So we choose this. Okay, we will make sure that we choose this. So this is number 3, the one that completes this entire scenario, right? So that we can call it our magic triangle. 3 things: right-angled triangle, the length of the hypotenuse, and an angle that involves two vectors. Once I complete this, together with what we have visualized through torcaso, then I can bring in these two tools super fast. Shall we try to see whether we can use this visualization and activate this magic triangle to help us to do some calculations? For example, right? Okay, we are not going to be doing very, very difficult calculations. Okay, you don't need to try super difficult questions in order for you to get vectors. That one day that I spent, I didn't look at any difficult questions. I just try to incorporate more visualization instead of just simply working on the calculation. In fact, I think for that one day, right, I spent most of the time trying to visualize the scenario and asking myself, if the scenario is seen by me, is visualized by me in this way, then how can the formula be calculating that unknown? So let me give you a situation, okay? What if I have a point, let's say A. Okay, let me not use A. What if I have a point, let's say P? Okay. What if I have a point P and if I have a point Q? What is the length of projection of PQ? What is the length of projection of PQ onto this line? This line is R is equal to A plus lambda B. what is the length of projection of PQ onto this line? Or sometimes they will say things like, what if there were to be a light that is shining from here, and then it is that, and there's a rod or something, that part that is like PQ, and this light that is shining from here, that where all the rays are parallel, are perpendicular to this line, right? Okay, what is the shadow? What is the length of the shadow that is going to be cast on this line, for example? Usually it's plate, but anyway, let's go for lines. So what is the length of the shadow that's going to be cast? So what is the first thing that you should do? You know what some students did? What formula should I use? What formula should I use? If you were to be doing this, right, you are missing the point. You're missing a most important point, although it is not written down most of the time in our solutions, but that visualization is how you trigger the entire solution. That trigger is more important than the solution that you're going to be writing down subsequently. Of course, the solution is still important, but without that trigger, right, the solution is going to be very, very challenging to be written down in a more precise, correctly. So let's visualize the scenario first, okay? What exactly am I trying to do? Incorporate this into the way that you're going to be doing any vectors question. So looking at this, by the way, I personally think drawing a diagram, right, is very, very useful for vectors. I see some students, they actually don't. Most students draw diagrams, okay, but I do see some students, right, not drawing diagrams, and most likely they are really very, very focused on just the formulas and the calculations, or maybe they are already visualizing the diagram in their head, which is very good. But if you are very focused on the calculations itself, right, of course, we are not going to be marked for a diagram that we are drawing in our script. Okay, so that's why some people thought that the diagram is just like an option. It is not an option. I will make it participate in terms of how I'm going to generate that solution. So for this scenario over here, I believe it is going to be something that is like this. Okay, geometrically, I know we are talking about this, and we are talking about this. So this is the length that I want to find. The shadow that PQ is going to cast onto this line if the light comes parallel in this way. Or the length of projection of PQ on the line. I'm going to find this. Let's activate our visualization, or let's try to find the magic triangle. Where's the magic triangle? Usually for our syllabus, right, the magic triangle is super easy to find. Isn't it obvious which one is the magic triangle? So I will go for a right angle triangle where the hypotenuse is known. Hypotenuse, usually when you choose the correct triangle, right, it is going to be known, so it's not a big issue. So we found this, and I am going to find this, which is actually definitely easy because we do have access to the coordinates of P. We also have access to the coordinates of Q, which means that PQ is something that is already known, which means that this is going to be the modulus of PQ, the distance of the hypotenuse I know. The third thing, which is like what I was telling you, is actually crucial enough for us to pause that little bit more and think, because I know that, like what I was telling you, I can imagine a lot of things, but it's not everything can be calculated. And I know that in our syllabus, right, we are going to be making use of dot and cross product. Okay, so I'm going to choose the theta wisely. I'm going to make sure that I choose a theta that involves two vectors that I know. Which are the two vectors you know? One is definitely this PQ. What is one more vector that you know? One other vector that I know, right, can be extracted from the equation of the line. So from here, we know that this line is going to be parallel to B, which means that it is going to be parallel to this here, parallel, right? And if I also have PQ that is obtained from vector P and vector OP and vector OQ, that means my angle theta is going to be assigned to this angle here. This is theta. Once I completed my magic triangle, I can just simply use geometry to do a simple calculation first, to just realign myself. What exactly is the distance I'm calculating for? Using Torcaso, I know this is modulus of PQ cosine theta, right? PQ cosine theta. Right? If you cannot see that it's PQ cosine theta, then just do your Torcaso all over again. Like for example, I have this, and this is R, and if this is X, if this is theta, then I know cosine theta is equal to X over R, which means that X is equal to R cosine theta. That is why here is modulus of PQ cosine theta. Okay? Cosine theta It is not any theta, but it is the theta that is between two known vectors that I have. One is PQ, the other one is B. Then I can start to use the two that we have been taught, which means that what I'm going to do next is PQ. I'll just do a quick calculation for it, which I should have already done. Then I use it to dot B, which I can very easily extract it from the equation of the line. This is equal to modulus of PQ, modulus of B, cosine theta, right? And what I want to find is actually modulus of PQ cosine theta. The good thing about dot product is scalar, 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 scalar. So this is scalar. I can divide it across to the other side, leaving me with just modulus of PQ cosine theta, which is what I want. So I have a modulus of PQ cosine theta. This is PQ dot B divided by modulus of B. Finding it as the length, I'm going to just put an overall modulus just to make sure that it is positive all the time. It is triggered by first your visualization. Let me try one more together with you, okay? What if I have this other situation? Let's make sure that we incorporate that visualization into how we are going to be generating our solution. Okay, and after a while, you'll realize the visualization will actually get faster and faster and faster. And that is when you're going to experience something that is also a little bit magical, which is you can actually write down without having to draw all the time because you are already seeing it happening. And that was what that didn't happen to me instantly after that one day I was telling you that I spent looking at vectors, but it happened to me subsequently. But of course, certain scenarios do require me to do a quick sketch because the sketching part is, to me, is very, very important. The sketching part is, in a way, disciplining myself to make sure that visualization is part and parcel of my process of generating the solution. Let me give you another scenario. So what if, okay, what if I want to find the shortest possible distance from P to the line L? R is equal to A plus lambda B. R is equal to A plus lambda B. I want to find the shortest possible distance. Some people will say, tell me the formula. Or some people will say, find the foot of the perpendicular. You know, unless you have already spent some time visualizing it, right? Or else, maybe you are super good in finding the foot of the perpendicular, but you are missing the point. That is not what you are trying to learn in vectors. What you are trying to learn in vectors is if you have already lived for the last 10 plus years and you are already able to see the geometry that is around you, but you have never actually spent time to see them as precisely as 0.1 something, I mean point something something something, then vectors can actually help you to do that. I don't know what that is going to be for, but anyway, coming back to this, right? This is the length that I'm trying to find. This shortest possible distance from P to the line L, right? I'm going to try to find this magic triangle thing. I think what I can try to do is to draw a triangle this way, because if I have a right angle and from this line, I can very easily get a point that is going to be on this line. So I have that number. I have this vector. I have the coordinates of this, which means that I will have AP, right? I will have AP. If I have AP, AP is not an unknown anymore. I do have AP. Then I will be able to very easily find modulus of AP, the length of the hypotenuse. Number 1, number 2, number 3. What is that number 3? Number 3 will be angle, because I know I'm going to use dot and cross product. Which angle? Angle that is between two known vectors. So there, here, and the other vector will be B that I've extracted from the line. So based on this, I decided that the angle is going to be here. And based on my tuakaso, I know that this length here is modulus of AP sine theta. Modulus of AP sine theta. And sine theta tells me that I should choose cross product. Because if I were to do a modulus of AP, modulus of B, taking these two vectors, I do a cross product. This is modulus of AP, modulus of B, sine theta. And because of this version of the cross product that I'm using instead of this version, this has both sides to be consisting of scalar, 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 scalar. So division is very, very easy because it's just arithmetic. I'm going to divide this B across to the other side because I do want one side of the equation to be modulus of AP sine theta. So modulus of AP sine theta will be, oops, I write wrong. This is supposed to be AP cross B. So it will be AP cross B divided by modulus of B. And this is how I'm going to produce my solution. This is fast. By the formula itself, it means nothing. And what you're supposed to do, right, is once you get it, like what I was telling you, because you have a lot of chance to practice this magic triangle thing. I mean, in vectors question, there were bound to be some parts that will require you to find some distances. So if you can just practice a few more times, after a while, right, you will realize, and it's natural, you don't even need to force it. You will realize that you don't necessarily need to draw the diagram all the time because you can really see it. You don't necessarily need to always go and actively look at the magic triangle because you already own it. So after a while, right, you realize that in the exam, because this has been practiced again and again and again. So ultimately, when you are trying to do the actual question, trying to find this, right, you realize that sometimes you will just say that the length is this, which is what I think some of us misunderstood when we see solutions that are given to us by the teachers. Sometimes teachers wrote out the solution as the length is this, but do you know how much has habitually gone through the teacher's head that is actually necessary to produce this solution? But if we were to misunderstand that and we didn't know that that actually exists, right, we thought that the teacher, pop, immediately come up with this solution. That is wrong. Okay, you cannot allow yourself to do something that is like this. Can I just try one more situation with you? And you try to see whether you can think alongside me, okay? What if, let me just give you one more distance scenario, okay? And you think about it. What if, how about planes? How about planes? Okay, so what if I have a point, how about if I have a point P again, and I have a plane pi, r dot n is equal to P, oh goodness, so many P. Let me just change this to Q, okay? So what if I have this? Can you find the shortest possible distance from Q to the plane pi? Find the shortest possible distance from Q to the plane pi. So to find the shortest possible distance from Q to the plane pi, I think what I'm going to try do is I'm going to find a point that is going to be on the plane pi, which is actually easy because if you have the equation of the plane, then any position vector that satisfies this r, which dot p will give you, which dot n will give you p, you will be able to extract different points that are on the plane. So assuming that I'm able to extract a point out from the equation of the plane, so I get an A, which means that there is no problem for me to know what is AQ as a vector, no problem. And since I have a right angle and I also know modulus of AQ, okay, what am I supposed to do? I'm supposed to find the shortest possible distance from Q to the plane, right? Where is that distance? The distance is here. Okay, I'm supposed to find this distance. What is next? Theta. You know, in situation that is like this, some students will put theta here and they will never find a magic triangle. You know why? Because they can never use the formula that is given. The formula requires theta to be the angle that is between two known vectors, right? So if I already know what is AQ, what is the other vector that I know? N. Because N is parallel to this. You know how you know is N? Because you pause and think. You know, students who didn't pause and think, of course they don't know where is N. How do you know that N is here? Yeah, because we pause and think about the situation a little bit. I consider the equation of this. I consider what I have. And with what I have, then it has to be N. It has to be N. So with N that is placed here, I know theta is going to be here, which means that this length here is modulus of AQ cosine theta. So if I were to do a AQ dot this length, this is N, AQ dot N, this is modulus of AQ, modulus of N cosine theta. And my aim is to find modulus of AQ cosine theta. And an alternative way that I can find this is going for an AQ dot N divided by, goodness, this looks like a 2. So AQ dot N divided by modulus of N. And I can calculate it the fastest using this. You understand what I'm trying to say? It is very, very important for you to be able to visualize. But like what I was saying just now, right? in your attempt to visualize, because we can really see a lot, I mean, like, for example, this. Why must I see a triangle? Why don't I try to see a square, or a rectangle? Why do I want a triangle? Because in order for you to be able to pen it down as your solution, there must be something that already can calculate that particular geometry. So we can imagine a lot of things, we can visualize a lot of things, but there are only certain things, right, that we have learned enough tools to try to manage them with numbers. That is why, what we are trying to do now, right, is, okay, we have the imagination first, okay? Then we learn about math, and then math helps me to craft, to filter that imagination, which is what I'm trying to learn, so that I can at least get the answer first. And if I'm interested in breaking that boundary, I can do some more research in my university. But if your intention is to do questions for H2 math question, incorporate this visualization into the whole process of how you generate your solution. And this visualization, right, can I just tell you one more thing? This visualization, there are a lot of things to visualize. I want you to spend that one day, if you are really going to spend some time looking at vectors, and if you were to be that one day, right, can I ask you to slowly sit down and either look through your school's lecture notes or look at all these little squares here that I have given inside the outline. All these squares here, right, are the common situations that are going to be happening. Okay, not all, but common enough. Okay, they are common enough, and I have already done my part in visualizing and filtering out how, through that visualization, how, if I were to look at it from this way, right, of course there are other ways to look at it, but if you were to look at it from this way, you will be able to calculate it using tools that you have faster in exam. So you try to go through this process. So all these little squares here, all these little boxes here, right, okay, you go through them together with the visualization. Don't just focus on the formulas. We let the formulas be the last. In fact, if you don't have time, right, focus on just trying to visualize the different scenarios first. You may not even be able to pass immediately because you don't have the formulas to use, but focus on the visualization first, because that is the harder part. And you realize that there are certain things, right, that even with your visualization, for example, like this, using the magic triangle to find the shortest possible distance from Q to the plane pi, right, in these boxes here, I do have something that is even faster, but it requires you to first visualize this magic triangle first. Like, for example, this process that is here, you can take a look at it, especially for those of you who are already attending our tuition, or those of you who have access to the Achevas TV theory outline, right? You can click on the video for this. You see how fast, even faster than the magic triangle, how fast the shortest possible distance from a point to a plane can be calculated. Super ridiculously fast. This is on the last page of your outline. What tools do I need? Is all the formulas considered as tools? Tools. Actually, right, can I just tell you that in your H2 math, they are equipping you with very, very powerful tools, but actually not a lot of tools. Most of the time, you're actually supposed to be working on your visualization, then questioning what tools, including those that you have learned in your secondary school, like, for example, Torcaso, Pythagoras theorem, okay, what tools you can use to calculate those things that you are visualizing. Okay, so most of the time you're actually trying to work on the visualization, but what tools? So in H2 math, right, they don't teach you a lot of tools, in case you didn't realize. These are the two new ones, or should I say the more higher level ones, because there are still some others, a little bit simpler, like, for example, unit vectors and stuff, So these two are two of them. You want to make sure that you know the tools super well. Because if you don't know them well enough, right, how can you even use them to do an important exam that is at the A level? Or for those of you who are J1, right, how can you use them to do your promo? Or those of you who have never even done vectors, I have nothing to say so far. So there are two more. There are actually just two more good and sharp tools, right, that you can make use, that you are actually learning, in order for you to solve problems that are like this. The second one, the third one, let me show you two more, okay? The third one is this. Hopefully, you guys are already familiar enough with these two. But my suspicion is some of you are actually not really understanding well what exactly this is about. let me try, okay? Let me try to talk about this a bit and you test yourself to see whether you actually know this tool or not. So if I were to say this is L and it is represented by this equation, R is equal to A plus lambda B. Okay, R is equal to A plus lambda B. By the way, Cambridge has asked this question before. What do you think is this equation representing? Cambridge has asked this before. No, I mean, not in a way that is as broad as the way that I'm asking. Okay, but Cambridge has asked something that is similar enough. What do you think this equation is representing? There will be quite a few people who has misunderstood this tool. They will think that this is the line. This is not the line. This equation is not trying to describe to you the line. If you want to describe this line, right, okay, this equation gives you insight. Okay, but it doesn't describe the line, but it gives you insight to the geometry of the line. By looking at this equation, I do know that this line is, yes, it passes through a point A that has a position vector of A. Position vector, so it starts from the origin. And this line is parallel to vector B. Okay, I mean, I can extract such information. I can extract. But this equation is not the line. You know, it is not the line. I think this is a very common misunderstanding since the secondary school. Secondary school, we look at this line mx plus c or line 3x plus 7. You know, secondary school we see this. This is an equation that gives you insight to that 2D line where I know that that line is going to be passing through the point 0, 7 and it has a gradient of 3. Okay, I can extract information from this to talk about the line. Of course, yes, I can. But this equation is not the line. What is this equation about? This equation is about points that are on the line. This equation is about points that is on the line. This equation is about that point x, y that is on that line. This equation is about defining a point that is on the Cartesian axis. Cartesian axis, you learn Cartesian axis for what? You learn Cartesian axis for coordinate points. It tells you coordinate points. So it is trying to tell you the coordinate points of all those points that lie on the line that passes through the point 0, 7 and has a gradient of 3. How can I define such a point such that it will always be passing through the point 0, 7, such that the path that it takes, right, will always be passing through the point 0, 7 and a gradient of 3. I can make use of tools. Tools, for example, gradient. If the gradient is equal to 3, that means referencing this to this, right, rise over run, y minus 7 divided by x minus 0 is equal to 3, which means that y minus 7 is equal to 3x, y is equal to 3x minus 7. I mean, if you really want to change, plus 7, if you really want to change it into this form, it is fine. But since this point onwards, since this moment, we are already able to define that point. And this objective of equation of line, which we call it in our secondary school, and now we also still call it as the equation of line. Okay, I think the titling itself, right, it is sort of like confusing. I'm not going to try to change the title, but I need you to see it from the correct perspective. This equation here is talking about a point that is in the 3-dimensional space that is going to be always lying on that path, and that path will always be passing through A, and it is parallel to B. So my objective, right, is just like what I've done in my secondary school, 2D lines. Now it is 3D. So for a 3D line, this is X, Y, Z, right? 3D line, X, Y, Z. Do we know the relationship between coordinate points and vectors? Yes. What is that relationship called? Position vector. Right? If I want to describe coordinates X, Y, Z, I use position vector. A vector that starts from the origin. Which means that if I want to try to describe this X, Y, Z, it is going to be a vector that starts from the origin. X, Y, Z. In our vectors, we call this general point X, Y, Z. I mean, we give it a symbol. pi. Pi is a symbol that represents something. We give it a symbol. The symbol is r. So this equation, right, is actually talking about r. The focus is r. The focus is the position vector of that point that is supposed to be lying on the line that is in the three-dimensional space. And the moment when you do this, you can actually try to do something that is like this already, because how can I make sure that this point, the position vector, where the end of the position vector, right, is always drawing out for me this line? Super easy. If I were to see from the vector's perspective, I just need to use vector triangle addition. So if I were to use vectors triangle addition, then r is equal to, if this were to be r is equal to this vector a plus this vector. Do I know this vector? I don't know exactly what is this vector, but I have insight to this vector because this vector is parallel to b. So if this vector is parallel to b, I'm going to go for a scalar multiple of b. So this is a plus lambda b, where lambda is the variable, a and b are numbers that made up the position vector of the, that make up the vectors. So if lambda is the variable, can you see how this equation can now give you all the points that are on the line? Because you just need to change lambda. For example, if you to just let lambda be equal to 0, what is r? R is a plus 0 times of b. So it is a. So where is r now? R is here, r. This will be r. And it is pointing to a point that is going to be on the line. What if lambda is equal to 1? That means r is equal to a plus 1 time of b. So it will be a plus 1 time of b, maybe somewhere here. Again, it gives you another point that is on the line. What if lambda is minus 2? Then r will be a minus 2b. You'll be a, b is in this direction, 1b, 2b's. So this is minus 2b. R is going to be here. It gives you another point. It gives you all the point that is going to be on the line. That is why, right, you need to know exactly what the tool is trying to give you in order for you to use it precisely enough. But of course, in exam, if you have been practicing it enough, right, when you are using it, you can almost take it for granted, provided that you have worked on it first. Okay, and understand and get yourself familiarized with it first. For example, let me give you a most basic scenario, okay? And let's see whether we can now see it even clearer. The moment we can see it even clearer, a lot of the other things that you're going to be questioned in vectors, right, will start to make sense. You know, our aim is to try to spend some time to visualize from those more fundamental ones that are in our lecture notes or in our outline first. Then slowly, they will stack one on top of another. Then it will progress to you being able to do maybe 50%, then 70%, and hopefully all the way until 90 to 100% of the vectors question. For example, let us go for the most basic kind of question that you see for lines. I have a little box here that talk about it. It is the foot of the perpendicular. Okay, it's easy. But let's try to see it from this perspective. Okay, so what if I have a point P and we want to look at a line L, which is this, plus lambda B, and our aim is to find the foot of the perpendicular. You know what I'm trying to do? I'm trying to visualize. That's the purpose of me drawing this diagram. I'm like what I was telling you, some students when they first saw this diagram, yeah, right, it makes sense. But they didn't put it into their solution because they thought that this was an introduction. Not important, but this is the meat. This is the crucial part of how this entire solution is going to be like. So based on this, we want to find the foot of the perpendicular. So what is this F? F is a point that is on the line L. F is a point that is on the line L. And what does this equation represent? Every point that is going to be on the line L. That is why I can say that OF is equal to A plus lambda B for a certain value of lambda, isn't it? You know, when I use this equation, you realize if you to just, okay, you don't need to study this, but if you are so bored during this holiday, right, you just go and look through all the solutions to vectors, you will realize, right, every time when they use the full equation of the line, they're actually talking about a point. Every time. Once in a while, of course, we are going to be extracting information from the line. That is different. Sorry, we are going to be extracting information from the equation. That is not using the equation. It is just extracting certain parts of the equation that make sense to you geometrically, so you are using it. But to use the full equation, right, you're always talking about the point. So now I'm talking about a point that is going to be on the line. That is why now this OF can be represented by R for a certain value of lambda. My aim is to find lambda. How do I find lambda? I visualize. I know that F is not any point. F is that point that is the closest distance to P, which means that if I can find PF, which is going to be OF minus away OP, OF minus OP, OP is given to us, then if I were to take PF dot B, it should be equal to 0, right? It's a very, very easy process. It's actually, the numbers are actually there. It's not even that difficult. But I just want you to try to see from starting from visualization, and we refine this part, just this part. Then I think this will really, really make sense because PF is perpendicular to P, to B. PF is perpendicular to this, 90 degrees. That is why if I were to take PF dot B is equal to 0, you know what happens? My visualization gets nourished. You know, when you can see, but you cannot calculate on papers, right? Something seems a bit missing when you're doing math. But when you can see, and yet you can actually bring that sight into your calculation, I don't know how to describe, but something clicks. So, so this, you know, bring all the geometry into your calculation, which means that you can put this into here, B, you plant it into here. There will only be one unknown, which is lambda in this equation. Then you can work out for the value of lambda. With the value of lambda, plant it back into here, you can find OF. You know what a student of mine told me before? This leaves a very deep impression within me, right? That tells me why it is very, very important to know the tools that we're using. You know, I remember after that particular vectors revision session, there's this one student. He's a new student, so it was only during that revision that I know him. Then subsequently he continued with the tuition, so I know him a little bit better after that. But I do know that he was a bit arrogant because his math, right, has been getting A all along. So I was asking him, oh, okay, you've been getting A all along, so what is your objective in coming to revision here? You know, so he want to make sure that he's really, really getting an A. So after the vectors session, we had a small little break. Then I saw him running down. Like running towards me. So he ran down, then he told me that, hey, you have just solved for me a problem that I've never actually managed to solve by myself before, which is actually this, This is a very basic question, but he has never solved by himself before. And please take note, he has been getting A for most part of his JC, and that was already JC2 like around this time, second year, mid-year. Okay, and he has never gotten this correct. You know why? Because he was a bit arrogant, and most importantly, he has misunderstood this. You know what he did? He did this. He will do this. He didn't know why he did this, but you know that this is part of the process that will help him to get an A. Then there's one part, right, that I think it was just him being that little bit more arrogant, so he refused to submit. Okay, so what he did here, right, this was where he got wrong. What he did here was, okay, he know that PF is perpendicular to the line L. PF is perpendicular to line L. But you know what he did? He did this. He did a PF dot A plus lambda B and let it be equal to 0. Because to him, this is the line. So it is definitely PF dot the line is equal to 0. He didn't know that you're actually just trying to extract out a portion of what this line has brought forth to the table and then use that as a number that represents something else, which is the vector that is parallel to the line L. So just this misunderstanding, he has been confused for, I don't know, like months. Okay, and the moment when he realized that, hey, this is not the equation of the line L, yeah, then it worked for him. Just like the last two that I want to share with you guys today, you can just stay with me for maybe 5 or 10 more minutes, right? It is this, R dot N is equal to P. It is a very, very useful equation to describe planes. Okay, and what is this R? This is not the plane. Okay, although it's called the plane equation, but this is not the plane. This is the equation that describe to you the same thing, the point that is on the plane. This equation is all about the point that is on the plane. This equation here, can I just write something that is on the board that is not actually very useful for your exam, but I'm still going to just write it anyway. So if I have a plane pi, and this plane pi, right, is perpendicular to this normal. And we know that this plane pi is going to pass through a point A. So assuming that the position vector of point A is given, so this surface passing through point A and is always perpendicular to this, it is a fixed plane. It cannot really move much anymore. So we have sort of like defined that plane according to our H2 math already. Okay, and if I can just tilt this plane a little bit, okay, let me tilt it a little bit, okay, then I'm going to see it as something that is like this, and 90 degrees. Maybe point A is here, this is plane pi, so we have this A, 0. Yeah, this is the plane, the physical geometry of the plane, right, need not require H2 math for you to understand. You just need to spend some time to sit down, to take a look at the plane yourself, look at an example that is like this, knowing some of the geometry that can describe for you the plane, it is done. Just like line, it is done. But what if we want to handle not just that surface, we want to handle so many points that is on the surface. So once again, we have the same objective where I have a point x, y, z. And I want to try to describe this point. So to describe this point from the perspective of vectors, I'm going to once again use x, y, z, the position vector of this point. So this is going to be r. So let me name this point here r. What if I will connect this to this? That means this will be ar. What is so special about ar? Which is r minus a. What is so special about this? This will be perpendicular to the normal vector, correct? Which means that in order for me to describe r, I can just let the plane be describing the position of r as r minus a, which is ar. Let me just write this as ar first. So it is this vector ar dot n. It is supposed to be equal to 0, correct? Which is r minus a dot n is equal to 0. This is the equation of plane. Done. It is already done. But in our syllabus, right, we like to do some simplification. Okay, so we can continue to simplify some more. So this is already good. Okay, we simplify this some more. We talk about this r dot n minus away a dot n is equal to 0. So r dot n can also be written as a dot n. But a is a vector that I know. N is also a vector that I know. So a dot n can be computed to a number, scalar product. So this can also be written as r dot n is equal to a number. P is a number. Some of your schools use d, then you will use d. So in our syllabus, right, we are more used to looking at the equation of a plane in this way, okay, which is this. But your objective is the moment when you use the full equation, you're actually trying to make use of x, y, z. When you are using the full equation, you are also trying to make use of x, y, z. Some of us, let me end off with this. Some of us, right, we feel very uncomfortable the moment our school starts plane. Can I show you the equation of a plane? In case you have forgotten the equation of a plane. Some of us feels that r dot 1, 2, 3 is equal to minus 5 is very uncomfortable. That is what you are taught, but this is very uncomfortable. I tell you, you are good in terms of how you have that potential to do well in vectors. If you look at this and you feel uncomfortable, you have the potential to do very well in vectors. You know why? The reason why you feel uncomfortable is because you are looking at the number. You didn't get to visualize the plane. That is why you feel uncomfortable. Do you realize those people who, just in case some of you are here, who feel uncomfortable with this, feel super comfortable with this? even though they don't really understand that this is not the line but the point that is on the line, but they feel super comfortable with this. You know why? Because through this, they don't focus on R. If you focus on R, which is not the most instinctive things to do, then you will be able to do some calculation for lines. Okay, but the focus, right, usually when people look at this is A and B. You know why A and B? Because A and B is something that you can see since you're a child. You're looking at things that are familiar to you. Not because H2 math introduced to you A and B, that is a line passing through a point. It has this kind of tilt parallel to these vectors. You can already do that before H2 math. You know, that's why you have this tendency to focus on A, B, point, angle, tilt, line. But the moment when you see this, right, 1, 2, 3, perpendicular to the plane. Goodness, -5 is what? If I have a plane that is always perpendicular to 1, 2, 3, right, isn't this plane just not defined yet? You know, it can still move about. You know, that's why some people, when they look at this, right, they feel very uncomfortable because the visualization part seemed to be missing. They felt comfortable with this. That's why it prevented them from exploring further what R is. But that familiarity also is not that helpful. Okay, so we need to channel our effort to R. We need to channel our effort to R. So what is this -5? Some people ask. Let me ask you also, if I have an equation of a line, y is equal to 3 over 7, x plus 4 over 7, okay? Let me multiply this. This is an equation of a line that you've learned in your secondary school, right? Let me multiply this by 7. So 7y is equal to 3x plus 4. Let me ask you now, okay? What do you think is this 7? Nivi, what do you think is 7? Okay, it is just the 7 that you throw it to the other side. 7 means nothing about the plane, right? It means nothing. It's just a number 7. Until when you bring over to the other side, 3 over 7 is the gradient. Until when you bring over to the other side, 4 over 7 is going to be the y-intercept. So it just depends on you. As long as you believe that this is the equation of the line, and if you want to find some geometry of this particular line, then go and find it. That's all. It is just a simplified version, but it doesn't mean that it is not the line. This, if you believe that it is the equation of the plane, you can definitely trace back. I mean, if you really want to see the plane that is going to be perpendicular to a vector and it is going to be passing through a point, looking at this, right, I can definitely substitute, let's say, -5, 0, 0 into this r, since r represents the position vector of any point that is on the plane, and we have learned before in our secondary school, any xy that satisfies this equation lies on that line. So if -5, 0, 0 satisfy this equation, replacing r is satisfy this equation, then -5, 0, 0 satisfy the line. If that is what you need, this plane is going to be perpendicular to 1, 2, 3, and this plane contains the point -5, 0, 0. And that is why when we try to find, for example, when we want to try to find, for example, I have a plane, I have a line, r is equal to a plus lambda b. I have a plane pi, which is r dot n is equal to p. Find the intersection between the line and the plane. You don't actually need a formula. You don't actually need another formula because you already know what to do. In a secondary school, what do? When two geometries intersect, curve, line intersect, line intersect. When they intersect, they share something on the xy coordinate. What is that? The xy coordinate point. They share the common point. Xy are the same. You solve it as simultaneous equation because they share the common point. At this particular point, the line and the plane, they share a common point, which means that they share a common r, which is x, y, z, correct? So find, for example, if the question were to ask you, find the intersection between the line and the plane. Equation number 1, equation number 2, I'm going to substitute equation number 1 into equation number 2. Then it will be a plus lambda b r, sub into this r, dot n is equal to p. Lambda will be the only unknown. You solve for the value of lambda. With this value of lambda, you sub it back into here, you will be able to find the intersection between the two geometry. Just by stacking your solution, by first applying your visualization, then trying to find these 4 tools, new tools, maybe with some that are from your secondary school. Practice how you can apply those tools, refine your visualization so they can create a good solution for that particular scenario. What scenario? Start with these few boxes first. Like what I was telling you in the beginning, right? Spend that one day, if you really want to do well in vectors, spend that one day, do nothing. You just commit yourself to do that one vector topic and see whether that is going to make a difference. I believe it is going to be. You know why? Because it's a very, very easy to study topic and it carries quite a lot of marks. Most likely, I mean, for those of you who are J2, most likely for your prelim, yeah, I'm not very sure, okay, but for your prelim and for your A-level, right, most likely there will be 2 vectors question. Of all the topics that you are learning in your pure math, each topic usually come out once, but vectors come out twice. And it's such an easy topic. Once you get it, it's really very, very easy. Okay, I'm going to end here. For those of you who are interested in joining me for a few more sessions during June, right? Okay, like what I was telling in the beginning of today's session, I have some topics that I'm going to be revising for pure math. For those of you who are J2, I have quite a lot of topics to revise actually, and we also have some for J1, not as much, but both are going to be as intensive as, both are going to be pretty intensive, okay? Probably the J2 will be a bit more in-depth, a bit more intensive, but J1 is not like it's going to be that easy also, but we are going to try to plow through it. If you have questions, you can ask me. If not, this is the end of my session. Do you have